Okay, we still continue with the laws of indices, as we said before now. So we've just dealt with one, that's the laws of multiplication and division. And in that situation, we are able to deal with numbers that were having the same base, and the relationship between those numbers were actually addition. That it doesn't stop with two numbers. So don't let's get it wrong. So we're going to do more on that. So it doesn't stop with two numbers. So that means you can have something like 5 raised to power 2 times 2 raised to power 3, then all over 2 raised to power 4 times 5. So how do we do this? So let's take a look at this. So we're applying the both rules now. Now, if you look at the two numbers here, the 5 raised to power 2 and the 2 raised to power 3, they are not of the same base, right? But when you look beneath it, that is these and these, they are of the same base, then these and these is of the same base. So you can as well rewrite these numbers like this. So it means 5 raised to power 2 over 5. So I'm rewriting it now, dot, or you can say multiplication. So you can just put a dot in place of multiplication. Then 2 raised to power 3, then over 2 raised to power what? 2 raised to power 4. Yeah, that's what we have there. So just for simplicity's sake, let me add this so that we don't get confused. So here we go. So the first thing we have to do is to deal with this one that had division. So that will give us 5, 2 raised to minus what? 1, based on the laws of indices. Then we say multiply. Then we also do the same thing to Barnabas, 2 raised to power 3 minus what? 4. So at the end of the day, we're going to have 5 raised to power 1, or just 5. Then here we're going to have 2 times raised to power what? Raised to power minus what? 1 in this. This is as good as writing 5 times 1 all over 2 raised to power 1. But don't worry, we'll soon get to this stage where we'll talk about the negative index. So that is just the first application of the rules, the first thing, the last thing we learned. So we can also check out some certain things we can do with it. So for example, you can have a number like 10 raised to power 2, then times 5 raised to power 3, then times 2 raised to power 2, and here we have 10 raised to power 10 times 5 raised to power minus 1, then times 2 raised to power minus 2. So let's see what we can do about this. So just as we did for the other one, so we can see this will go with this with this, and this with this. So let's write it out. That means we're going to have 10 raised to power 2 over 10 raised to power 1, which is actually 1, 10, sorry. Then we have times 5 raised to power 3 over 5 raised to power minus 1. Then here we have times 2 raised to power 2 might divide by 2 raised to power minus 2. So we are taking them one after the other. So the first one, we want to take that, apply the law of indices, which is division rule. So we're going to say 10 raised to power 2 minus the power here 1. Don't forget there's an invisible 1 here. Yes. So then times 5 raised to power 3, then minus 1. So you can see this is having a base of -1. So you're having 3 minus 1, then times, then 2 raised to power 2 minus 2. So let's take the first one. The first one is going to give us 10 raised to power 1. That's 2 minus 1. That's 1. 10 raised to power 1. So you can just leave it the way it is. Then you have 5, because 10 raised to power 1 is the same thing as 10. So we also have 5 raised to power 3 minus, in your sign rule, minus times minus in sign rule is plus. So here we're having plus 1, then times, this becomes 2. The same thing applies here. 2 minus times minus give us plus. That's plus 2. So at the end of the day, we are getting 10 times 5 raised to power 4, then times 2 raised to power 4. So you can leave your answer this way. So that is it. We just apply the first laws of indices. That is the law of the multiplication and division, or what you guys normally call the law of addition or subtraction, as the case may be, maybe because of the power. We'll meet in the next class.